we're classifying quadrilaterals, we want to start by looking at what evidence the diagrams are giving us. We can't classify any of these shapes by what they look like. Instead, we have to go by what the evidence tells us. So the first thing that I do is I usually make a note of what I'm seeing. In this first figure, I'm seeing tick marks on the diagonals. So the property that that's showing me, according to the properties on my properties chart, is that diagonals bisect each other. And I want to make sure I say each other because we do have a separate property that says diagonals bisect angles, which is not what this is showing. And in fact, that's the only thing I can see from this diagram. So looking at my properties chart, I can see there's actually 4 properties that this that could match up to this quadrilateral. That's the parallelogram, as well as all the other figures in that branch of our family tree. So the rectangle has that property, the rhombus has that property, and then the square also has that, because those are all specific types of parallelograms. So my default name would be parallelogram because that's the least specific of all those names. However, if I can prove something else, I could try to be more specific and get a rectangle, rhombus, or square. Unfortunately, there's nothing else in this diagram. I don't know for sure that those are right angles. They certainly look like they might be, but just because they look like it doesn't prove it. I don't know if the sides are all the same length, so I can eliminate those as options. My default name is going to be a parallelogram. That's the most specific name that I could give this figure. Next up, I'm noticing that I've got sides this time that are given to me. So I would probably begin trying to figure out what property this is by looking at my properties charts under the sides properties. And it's not that opposite sides are congruent. I can see that those don't match up. Instead, it's that sides that are next to each other are congruent. So I'm going to note that property. We had labeled that as consecutive sides congruent. And according to that property, there's only one quadrilateral that fits that, and that's the kite. So this figure must be a kite. I know it's not going to be a rhombus or a square because the sides aren't all the same. It's just the two sides next to each other are the same. So that makes this quadrilateral a kite. Next up, I'm noticing that this figure, this quadrilateral, has parallel sides. Those little red triangles mean that those two sides are parallel. So the property that this figure is telling me is that I have one pair of parallel sides, which means I have two figures that this could be. It could be a trapezoid, which would be my default name. That's the less specific of the two, or it could be the isosceles trapezoid. But in order to prove an isosceles trapezoid, I would need to know something more specific. So let's go one step further. In addition to showing that I have one set of parallel sides, they've also given me lengths of diagonals. So I can see they don't bisect each other, although that's not a property of any kind of trapezoid. Instead, what I would be more curious about is the lengths of those two trapezoids, because an isosceles trapezoid would have equal diagonals. I can see that on my properties chart. So let's add up those pieces together. I've got 75 and 62. The other piece is 64 and 80. And actually, even without adding them, I can see that those diagonals are not congruent to each other, which means this cannot be an isosceles trapezoid. If it was, those two diagonals would be equal. So the best name I can give this is going to be a trapezoid. And last up, I can see that tick marks on all 4 sides that match up. That is the evidence, or that's the property, that I've got 4 congruent sides. All sides are congruent to each other. And what that means is I have 2 options. This is either a rhombus, which would be my default name because that's the less specific name, or this could possibly be a square. But in order to prove a square, I would need to know something more, something about the diagonals possibly, or the angles, and I can see that I don't have any more information, so there's nothing in this that can be used to prove it's a square. Even though it looks like a square, I can't go by what it looks like. The best name I can give this figure is a rhombus because it has 4 congruent sides. We can also use our properties to investigate whether a quadrilateral is a specific type of quadrilateral. For example, in this case, we want to know if this is a trapezoid specifically. Well, to prove something's a trapezoid, I would need to know probably that I have one pair of parallel sides. There's maybe other ways I could do it, depending on what figure I have, but in this case, I want to prove that I have one pair of parallel sides. And I can see that if 2 sides were parallel, it would be those 2 sides right there. Although going by looks is not going to be enough, I could try to prove that those 2 sides are parallel. And what I'll do is take a look. If you guys remember back when we did our parallel lines and transversals, if I look at this, I've got a set of consecutive interior angles, or same side interior angles. And I can see that if I add those two angles together, they do add up to 180. And that actually was the proof that we used to say that these two lines are parallel to each other. As long as our same side interior angles were supplementary, we could say the lines were parallel. So because I know that those two lines are parallel, I do know that I have one set of parallel sides, which means I do in fact have a trapezoid. This figure is definitely going to be a trapezoid. And then the last part of this question asks us to go even one step further. Is it an isosceles trapezoid? Well, to do that, I would have to prove something more specific, either something about the diagonals or something about the angles. So let's see what else I know from this diagram. I can see that these two angles right here, we call those base angles because they're on the same base. Those angles are congruent to each other. And the same would be true if I looked at the angles on the QR side. Those two angles would also be congruent. That specific property, that base angles are congruent, means we can actually go one step further and we can say that this is an isosceles trapezoid. A regular trapezoid will not have congruent base angles, but an isosceles trapezoid will.